Bonjour, c'est le rayonnement et la chambre du nuage, which is radiation in cloud chambers, and it's the good lab of Crab and Colin. Look, it's the sea bear. Wow.
Okay, so what we did in this lab was we made we made one, but we had others. Something called cloud chambers, which is a tool used to detect and study radiation. Here's one that we tried to make out of a fish tank. This one was given to us by the good doctor, and this is the chamber of secrets, something like that.
Okay, so what is a cloud chamber? What is cloud chamber? Sure. So basically, this is what we did too, is we took some dry ice here, which is super cool stuff. You should play around with it, but be careful. Some black lining in here. You want some light to get in so that you can see things. You need some alcohol. Preferably, we use like 92% isopropyl alcohol, and you're gonna soak some felt or something here. It's an alcohol wick, and then a containment and a transparent lid. Sure, why not? And so what happens is you look, and you get. Oh, sure. Oh, we do have an image. Okay, cool. We'll take this one. So you'll have this dry ice, which cools this chamber here. And then also your alcohol is, because it's very volatile, it'll create this gas that disperses in this chamber. So actually what happens is the entire gas that's in here becomes very cool, almost to the point of liquefying. You'll get radioactive particles which move through the air pretty fast. They're really cool. It will polarize your alcohol, and then they'll condense on itself. And so you get really cool looking like liquid alcohol trails moving through this chamber.
And this one's about radioactive. So radioactive basically means that the thing is unstable and it's releasing something. So they have some fundamental particle in the nucleus, and the thingy, the atom, will reject the extra charge or energy because that will make it stable. So it'll go back to a balanced charge energy state. And so we see that in alpha radiation, beta radiation, and gamma radiation. And here are different examples of what you would see in a cloud chamber from each different kind of radiation. And we'll get more on that later. But alpha particles are like this, beta particles squiggly.
So this is what our chamber that we used and worked kind of looked like when we were using it. So on this side you can see some pretty thick, pretty straight trails that are moving through here. Really, really clear, really cool to look at.
You can see trails here, here, and there, as well as here. That one was more wispy, didn't produce as much activity as this one.
It's kind of sad. So we used sources that gave off a specific particle. In this one we have alpha decay, which is just essentially a helium nucleus that's being launched out of this source. They're very angry, I think at least. They produce these very clear, these very straight, bright, clearly defined tracks. They're really easy to see, actually. Unfortunately, the beta particles are not.
It's because like the beta particle is just a little electron, whereas the helium nucleus is made up of 2 protons, 2 neutrons. Yeah, and it's a lot bigger, so I'm guessing that's why it's easier to see.
Really regular, thin, and sad frowny face. We failed, big time.
That's right. All the stuff you saw before that was in the little cloud chamber was like the size of a. It was actually. Was it made of petri dish?
It was like this big-ish.
It was really small. We tried to make a bigger one to capture gamma rays out of a fish tank that I had, but it did not work.
Yeah, we were like, so when we were making it, we were sure it was gonna work, right? We were really happy, and we were all like full of hope, and then our dreams were crushed, unfortunately. So what we think happened was our source might have it was probably already decayed, or like there was some issue there, or there wasn't enough alcohol in the chamber itself. When we were trying to get alcohol into the chamber, the issue is it's so extremely volatile, and when you're putting things into a chamber, you usually have to have like an open top so that you can get your hand in there. So I think that the alcohol was escaping out the top.
It's funny. We had like the whole chamber lined with felt, and we had it all soaked with alcohol. Like if you stuck your face in there and like inhaled. Never mind. But there's a lot of
high school.
Point is, it was like there's a lot of alcohol. Never mind. Ignore that part. We had it very saturated, is what I'm trying to say. And if we didn't see it was that saturated, you're trying to wonder like what else could have caused it.
Yeah, so there also might not have been enough light to see anything, or the background felt wasn't dark enough. It might not have gotten cool enough. The issue is that it's such a big area that it's hard to cool down, and we bought like 15 pounds of dry ice, and it just didn't work. We're just not cool enough, I think, is actually the laws of physics just kind of hate us, you know.
So, in this lab, we learned that radiation is a thing, it is real, it exists, and we learned about the differences between alpha particles and beta particles. We did not see any gamma particles. We would see those in the form of gamma radiation, which is just like coming from space. But we were not able to get that part to work, sadly. And then,
yeah, we learned some stuff about stability, so like, you know, just kind of how the makeup of the atom, and if you have a very unstable thing, it's interesting because it just really doesn't want to be unstable, so it's like trying to repair itself, and it rejects some stuff, and then other stuff becomes unstable, and then sometimes people die because of this, but you know. Also, we're failures and yet somewhat successful. And we have some videos, but while he's pulling that up, let's talk.
Yeah.
We tried to do it first in my basement. That didn't work. Mainly, I think it's mostly because of the chamber that we used, it was kind of bad. But also, you know, we're surrounded by concrete. You should do the other one. The other one's better. Yeah.
there, you can see some.
Oh, well, you know, every once in a while you'll see a couple shows. It's really, this video just was horrible.
This is the one I took.
No, the one you took was bad too. It's just, well, also part of it is that this is beta, so it's really hard to see these ones. It was hard for us to find them. It was hard for the camera to find them. It just sucked. I took a video of the alpha particles, and it's amazing. Like, they're so easy. There's so many of them. It was really cool.
There's one.
Can we
do the alpha one?
I don't know if we have that.
It should be on there.
Just start enjoying the beta particles.
Alpha particles are better.
Where are those beta particles coming from?
They're this source.
Oh yeah, this thing's the radioactive source.
You have a source in your basement?
Oh no, we did that part here.
This is cool. Okay.
Yeah, this is. I don't own radioactive.
Okay, that's the right thing to say for the internet. Good idea.
Dude, why is it on here?
Non-existent.
That makes it.
Wait,
Maybe it's in
wait.
data. There we go. There it is.
Prime, what is your source?
10 seconds.
I think we used some iron.
Shoot. Okay.
Oh my goodness.
Okay, there.
Oh, that's all.
The end.
Dang.
Oh.
We're gonna stare at this for a few
Radiation
minutes.
at work, guys.